We're going to look at how we factorize quadratics, expand, and also simplifying. Let's start with expanding. So to expand quadratics, you should always use the FOIL method, where you take the first one of both, then outside, inside, and then the last two terms. So there are also special expansions that you should know. So the perfect squares, which are written underneath them, and then you also have the difference of two squares. All right, here's an example on the right. Expand all of that and state the coefficient of a term in x. So we have the first one, there's a 2 in front. Leave that outside because we should always be doing squares first. All right, in this first one we have a perfect square, so we have 16x squared minus 4 times 3, which is 12, but remember to double it. So that gives us 24x. Then we have 3 squared, which is 9. Then the next one, you have a difference of 2 squared. So that's x squared minus 4. Notice I left it in brackets with a negative in front. You should always expand that last so you don't forget it. And then the last little bit here, use the FOIL method, so we get 2x squared minus x plus 10x minus 5. Expand all the brackets, 32x squared minus 48x plus 18 minus x squared plus 4 plus 2x squared plus 9x there minus 5. I'm going to use different colors here. I'm going to underline all the like terms. Now don't forget, when you work out the like terms, the sign in the front always follows the number after. So we have 32 minus 1 plus 2, so that's 34 minus 1, which is then 33x squared. Then I'll use yellow, I suppose. So you have negative 48x plus 9, so that gives us negative 39x. Then you also have plus 18 plus 4 minus 5, so that's 22 minus 5, which is then 17. Okay, factorizing. So we're going backwards from expanding. We need to find common terms and then factorize them out. Okay, so the first one, we have an x term in the front. X is common. There's no y's on everything, so we just leave it at that. And there's no common numbers that you can take out. So it should be 2x squared in the bracket plus 5xy minus 12y squared. You might then notice this is a quadratic, which means we can factorize it further. So we need a 2 and a 12, and it's negative, so one of them must be negative. So that we can multiply it and subtract it so we get a plus 5. So let's try out some numbers. Let's do 3 and 4. We need to be able to subtract a 3 so we get an odd number. So then we must be that. And it's positive, so the smaller one must be negative. So then we have 2x and an x there. And we need the 2 to multiply the 4, so we need 4 there. And then the 3 to multiply the x. There's a y term at the end, so don't forget to put the y's down. Alright, part B. This one we can factorize in 2's. So if we do the first two, we have 4y squared minus x squared. So then we must have 2y minus x, 2y plus x. And then the other part we have 5 that we can take out, which then gives us x minus 2. Oops, accident. 2x minus 5. Sorry, I just noticed. If you look at this last section of the terms, that's actually a perfect square, so we can actually factorize that. Let's factorize up the negative part. Then we get 4y squared minus, it's a perfect square, so it's x minus 5 squared. We now then have a difference of two squares. So we take the first one, square rooted, minus the other one, then add the other one. Alright, C. So there are some instructions there to help you on C. We can use substitution to work it out. So instead of x plus 1, we're going to substitute it with an a. We can then factorize that out, so we get 7a, it's a negative 8, so it's minus 1, a minus 1. Then we substitute the x plus 1 back in. So then we get 7 bracket x plus 1 minus 1, then x plus 1 minus 1. Expand out our brackets, then we have the final answer. Now if you want to, you can leave it at that, or you should be putting the x in the front. Okay, sums and differences of two perfect cubes. It's written for you on the side. Now just take note, the most common mistake most people make is they write a 2 there. There is no 2 there, because we need it to cancel out. Okay, so factorize x cubed minus 27. Now, if you have a minus here, this first bracket is always a minus, second one plus. So then we have x minus 3. Oh, sorry, I jumped a step. My fault. You should always rewrite it in terms of 2 cubes. Then you write it out. So it's x minus 3, x squared plus 3x plus 9. Part B, do a similar thing, but you might notice you can factorize it first. So that we get x cubed plus 8, which then means we can change it to 2 cubed. Once we've done that, then write it out as of above. So if you have a plus in the middle, then the first bracket is a plus, the second bracket is a minus. Alright, so solving algebraic fractions, always factorize first and just divide. So the first one, we have x squared minus 2x, in the factorize that on x. And then the bottom one factorizes to x minus 3, x minus 2. The x minus 2's are the same, so they cancel out. So we're left with x over x minus 3. Part B, the same thing. We have x to the power 4 minus 1, then x squared minus 1, x squared plus 1, because of the difference of two squares. Bottom is x minus 3. Now, because we're dividing a fraction, keep the first one as it is, change the second one to a times, and then flip the last one. Now, I've noticed here it's x minus 3 on the bottom. On the top of the other one, I can factorize that on negative, so they're exactly the same. Don't forget to do that. If you forget to factorize out in negative, your answer will not be correct, because you then have a negative version of it. Alright, so those two cancel, so we're left with negative x squared minus 1, which is 1 minus x squared. Now, to add and subtract fractions, we need to factorize it first, that we can have the same denominator. The first one we have 3, 1, factorized. Second one we have x minus 2. Then the last one we have x minus 2 plus 1. Alright, then make sure all of them have the same denominator. we have a 3, an x plus 1, and an x minus 2. So they should all have that underneath. Now, in the first one, we're missing an x minus 2, so multiply that. The second one, missing 3, and also x plus 1. And the last one, missing 3. So then you can leave the bottom, you don't have to expand it out. The top one, however, you so then simplify anything you need to. The 3x's cancel, so we're left with 2x minus 7 all over 3, x plus 1, x minus 2.